So in this video, we're going to solve quadratic equations that have complex solutions, and we're going to solve quadratic equations that can utilize that square roots strategy. So if we look at the equation on the screen, we know that this is in fact a quadratic equation because of this x squared piece here being the highest exponent of x. So the highest exponent of x will always be 2 in a quadratic equation. Now, if we want to solve a quadratic equation, if there's only one x in the problem, our goal is to start by getting this whole piece that is squared by itself. Because if I can get that piece by itself, I can then square root both sides in order to solve the equation. So here, we're going to start by subtracting 10 from each side. So we have x squared is equal to negative 36. Now from here, we know that we want to get the x by itself. So we're going to square root both sides. And what you need to remember here is that when we square root a squared value, our x value is going to be equal to plus or minus the square root of negative 36. Remember that plus or minus piece needs to be in there. Now, when you took Algebra 1, this is where you typically would stop and say, well, I can't square root a negative number. If I do that in my calculator, I get an error. So this is no solution. However, in Algebra 2, what we know is that this is really saying there is no real solution. But it doesn't mean there's not a solution. So we now have knowledge of the imaginary I and the complex number system. So what we're going to do from here is we're actually going to simplify this square root right here using our knowledge of the imaginary I. So remember, we can simplify this square root by rewriting this as the square root of negative 1 and the square root of 36. Because remember, the square root of negative 1 is equal to that I value. And then here, the square root of 36 is 6. So really what we find here is our answer to this equation is x equals plus or minus 6i. So what that's really telling us is that x can equal a positive 6i or a negative 6i. X can equal either of those. So while there's no real solution, there is an imaginary solution. So in Algebra 2, we now keep in mind that we can find imaginary solutions that use that imaginary number I if we end up with a square root of a negative number like we saw up here in our second step. So let's try another example together here. Note that we just have a single x in the problem and it's encompassed inside of a square. So our goal here is to get that x minus 5 quantity squared by itself first. So we're going to start by adding 40 to each side. So we end up with 2, and then x minus 5 quantity squared is equal to a negative 162. Then divide both sides by 2, so we end up with x minus 5 quantity squared is equal to a negative 81. So now in order to undo that squared, we need to square root both sides. So we have x minus 5, and remember, because we square rooted a squared, we have plus or minus the square root of a negative 81. Now from here, we know that we can simplify square roots that have a negative underneath as long as we rewrite them as the square root of negative 1 and the square root then of the positive version of that number. So the square root of negative 1 is I, and the square root of 81 is 9. So what we end up with is x minus 5 is equal to plus or minus 9i. And then what we can do is we can add 5 to each side. So we end up with x equals plus or minus 9i plus 5. Now, typically if we write this complex number that we see here into standard form, you would write this with the real part first. So it would be x equals, it's a positive 5 plus or minus 9i. That's really the better, more accepted math way to write it. And then if you like to write this as two separate answers, you could write this as x equals 5 plus 9i, and then x equals 5 minus 9i. So those are the two complex solutions that we have to this original quadratic equation. So let's try an example that's a little more complex here. So again, we start by getting this piece that is squared alone because we only have one x in the problem. So we add 10 to each side, so we have 4 times 3x plus 3 quantity squared is equal to negative 240. We then divide both sides by 4, so we end up with 3x plus 3 quantity squared is equal to a negative 60. So then at this point, we know we need to undo that squared, so we're going to square root both sides. We know when we square root this squared here that we get 3x plus 3 is equal to plus or minus the square root of negative 60. Then from here, I know that I need to always pay attention and see if I can simplify this square root. So I know that I can write this as negative 1 to help me get rid of that negative inside of there. And then when I look at 60, I notice that 60 is divisible by one perfect square, which is 4. So I'm going to rewrite this as the square root of 4 times the square root of 15, because 4 times 15 gives me 60. So then from here, this becomes plus or minus, square root of negative 1 becomes I, the square root of 4 becomes 2, and then I have the square root of 15. So if I simplify this just one more time, I'm going to get plus or minus 2i times the square root of 15. So while that is a little bit complicated, we are able to simplify it. Now from here, I'm going to start to get the x alone, so I subtract 3 from each side. So this would become 3x is equal to, you can write it as plus or minus 2i times the square root of 15 minus 3, but it is more common practice to write the real part first. So I'm going to write this as 3x is equal to the negative 3 plus or minus 2i times the square root of 15. Then from here, we need to get the x by itself, so I'm going to divide both sides by 3. So I have x is equal to negative 3 plus or minus 2i times the square root of 15 all over 3. And then if you really want to pay close attention to detail, you'll notice that negative 3 over 3 can be simplified to be negative 1. So we can actually rewrite this final answer to be x equals negative 1. Then it will be plus or minus 2i times the square root of 15 over 3. So this is the most simplified answer that you could find. If you left it like this, I would understand and that would be fine. But if you really want to get good at your simplifying, this is the most accepted complex answer. So finally on this slide, I'm going to show you how we can use the square root strategy to solve for both real and imaginary solutions. So we have two examples here. One of these examples has two real solutions, and one of these examples has two complex solutions. And we'll talk about which one has which at the end. So in problem number 1, I know that I need to get this squared piece by itself. So I'm going to start off by adding 5 to each side. So I have negative 2 times x minus 5 quantity squared is equal to negative 50. Then we divide both sides by a negative 2, so I end up with x minus 5 quantity squared is equal to a positive 25. So then I know I need to undo that squared, so I'm going to square root both sides to undo that. When I do that, because I'm square rooting a squared, this is going to be x minus 5 is equal to plus or minus the square root of 25. Then from here, I know that I need to simplify this a little bit further. So I have x minus 5 is equal to plus or minus, well, the square root of 25 is just 5. So notice that I did not need the imaginary I here because the number under the square root was a positive number. Then from here, I'm going to add 5 to each side. So I have x is equal to plus or minus 5 plus 5. Because these are all real numbers, I am expected to find both solutions. So I have x equals, this is a positive 5 plus 5, so that's 10. And then I have x equals a negative 5 plus 5, which is 0. So I have two x values here, x equals 10 and x equals 0. So I can see here that I used the square root strategy and I came up with two real solutions. There's no imaginary I, so these are two real number solutions. Now let's take a look at this next problem over here. So again, I'm going to get this squared piece by itself. So I subtract 6 from each side, so I end up with 3 times the quantity of x minus 5 quantity squared is equal to negative 147. I then divide both sides by 3 and end up with x minus 5 quantity squared is equal to a negative 49. Then from here, I know in order to undo the squared, I need to square root both sides, and because I square rooted a squared here, I get x minus 5 is equal to plus or minus the square root of negative 49. Now because I have a negative underneath my square root, I'm going to have to simplify this a little bit. So I know I can rewrite this as the square root of negative 1 and the square root of a positive 49. So then I can simplify this a little bit. This becomes plus or minus, well, the square root of negative 1 is I, and the square root of 49 is 7. So I have x minus 5 is equal to plus or minus 7i. And then we need to get x by itself, so we add 5 to each side. So we end up with x equals plus or minus 7i plus 5. But remember, the best way to write your complex imaginary solutions is with the real part first. So we have x equals 5 plus or minus 7i. So that accounts for both answers, the answer where it's 5 plus 7i and the answer where it's 5 minus 7i. So here, because we have i's in our solution, we have two imaginary solutions. So you can see real solutions do not have the imaginary I, and imaginary solutions do have this imaginary I piece there.